Hello guys, it's been a long time, and after a long period of time, we are back to continue our playlist where we are teaching engineering chemistry and we are trying to cover an important topic of surface chemistry, which is colloids and colloidal solution. So, in our previous lectures, we have tried to understand how colloid is prepared mechanically. We have seen that there are two types of colloid, one is leophobic and another one is leophilic. It is very easy to create leophilic as it attracts water. You just can shake to prepare it. As for the leophobic, you need artificial preparation method, and we have seen a lot of methods as well. And in today's video, we will be talking about the the mechanical dispersion by colloidal meal. Why do we need to use a mechanical colloidal meal? The reason is that suppose we have large coarse particles, like if this is a jar and we have large particles, it easily creates precipitate. I hope you understand. It easily creates precipitate. So the key concept is that in order to make colloid, we must break particles down to the size of the range of 1 nanometer to 1000 nanometer. So what we'll try to do, we'll try to break it down into very small nanometer size, ranging from 1 nanometer to 1000 nanometer, 1 to 1000 nanometer. We all know this. So this is basically the reason why the size matters and why we're trying to cut it down. So in the mechanical method, the component we have, there are key two parts of the component. One is rotating disc, another is the stationary disc. There are two discs, like, which are literally vertically with each other, and they are parallel as well. So when when the big particles are fed through the narrow gap between this disk, one disk spins at high speeds and the gap is incredibly small. So I think what happens is that when big particles get inside the gap, it just cuts the particles down. You can see the process here. It can easily cut the particle uh, down, and this creates a shear force. If we try to see that there is a force created when a disk stays still, and above that another disk starts to starts to spin like that at high speed. What happens is that when particle go through it, this disk, the disk above, creates shear force. I hope we all know what shear force is, because in it is very basic physics. The shear force is basically when you take a uh, quadratic like that, and you just put pressure and it just bends itself. It just creates this difference of theta, and that is the force that is put through the surface here is known as the shear force. So what happens is that the liquid is being pulled in two different directions at once, tearing the large particles apart into colloidal size. And if we see real world application is that we use it for ink and paints. The pigments must be tiny to flow through, and we also use them in cosmetics. We also use them in food, which is mayonnaise and peanut butter, ensuring a smooth and consistent texture. Obviously you might think that this is a perfect method, which it is not. I think in science basically every method has some flaws. So what happens is that due to this two disk that They generate excessive heat due to friction, and this can be bad for delicate substances like protein or certain medicines. And what happens is, just because you broke the particles down doesn't mean that they will stay that way. They might want to clump back together, and that clumping back together, the process we all know it as coagulation, which is why we often add stabilizers to stabilize the colloidal solution. We know that we have used in the previous lectures an electrolyte named KOH. A lot of electrolytes can be used, but this is a specific one that we use normally. To give an example, so uh, this was the part. It was a very easy thing to understand. My suggestion would be that after hearing or watching my videos, you should do some research over it in order to solidify your concepts. I always try to preach self-learning because that is the only way that you learn. I can only show you the topics and how it's done. So I hope that's it for today. We'll see you in the next video.